Good afternoon, everyone. All of you who braved the mile-long convention center to come to room 386. How ironic that we're in the 386 room. My name is Chuck Heinzelman. I'm a senior program manager on the team formerly known as SQL Server CAT team. We are now called the Azure CAT team because we do so much more than just SQL Server. What we're here today to do is just have an open forum with some of the engineers that are working on SQL Server and infrastructure as a service combined. Okay? There is no slide deck. There is no formal agenda. This is your opportunity to ask direct questions of the people who are building and designing the product. If you don't ask questions, I have to ask the questions. And you might not learn what you want to learn. Okay? I'm going to have these guys introduce themselves and tell you what their specialty is, but don't limit your questions. You know, we have a breadth of knowledge here. If we don't know the answer, we'll make something up that sounds realistic. I don't even get a chuckle out of that? Wow. I'm hurt. So just to tell you a little bit about my specialty, I deal with SharePoint BI, mostly infrastructure. So I've been doing a lot with that in infrastructure as a service with scaled out deployments of SharePoint. Couple of logistics. We have 2 microphones in the aisle. If you want to ask a question, please use one of the microphones so it gets on the recording. Okay? And other than that, no questions are off limits. They might not answer them. But go from there. And so I'm going to let the guys introduce themselves. We'll start with Sanjay.
Hi, I'm Sanjay Mishra. I work in the CAT team, the same team as Chuck. And CAT stands for Customer Advisory Team. So we advise customers on how to build best application, how to best use our product. At the same time, we take advice from customers how to build, how to make our products better. And I've been in this team for over 8 years now. My specialties are high availabilities in all forms, especially database high availability, OLTP applications, scale up, scale out, and everything in between. And I am also involved in the SQL Server side, SQL Azure side, and SQL on infrastructure services. I'm glad to be here. Thank you.
Hi, my name's Guy Bowerman. I'm a program manager in the SQL Server Cloud Infrastructure team. I've been in this team for about 3 years. We've been overseeing the certification of SQL Server on Azure VMs. Main things I've worked with over that time: SQL Server virtualization, SQL Server resource governance. I've been working on some of the hybrid cloud features in SQL 2014. I also do a lot with private cloud. So at the conference this week, I was talking about private cloud and also SQL Server performance in Azure VMs.
Hi, everybody. I'm Drew McDaniel. I'm a program manager, senior program manager in the Windows Azure team. I've been working on infrastructure as a service. I think I started a few months after Mark Rusinovich really started the idea of IaaS VMs in Windows Azure. And so have been doing that for about 2 years, specifically work on the API interfaces for infrastructure service, the set of platform images. We're going to harass these guys about the SQL images that we have in the gallery. As well as if there's any questions on kind of the platforms as a service and how you can leverage some of that. I'm also responsible for the compute infrastructure for platforms as a service. My team also does the PowerShell tools for compute, and so some of the automation, we'd be happy to talk about that as well.
Hello, everybody. My name is Luis Vargas. I'm a program manager in the SQL Server team, specifically in the high availability and disaster recovery area. So for the past almost 4 years, I've been working on high availability. I've been working on Always On, so people who are familiar with the next generation of high availability solutions in SQL Server 2012, SQL Server 14, I've been working on that. So in the context of this talk, I've been working on bringing SQL Server high availability and disaster recovery into Windows Azure VMs and enabling the scenarios like ensuring high availability for your SQL Server running in the cloud, as well as for hybrid scenarios like having disaster recovery for your on-premise SQL servers by maintaining replicas in the cloud. So if you have any interest about these scenarios, please feel free to ask any questions.
Hey guys, I'm Mahesh Tyagarajan. I work in the infrastructure services team with Drew, and I work a lot on the the compute side of things. We write we work on the APIs, PowerShell tools, and all of that. And I specifically focus a little bit also on enabling a lot of networking scenarios. So anything that you got to do with point-to-site, site-to-site connections, and enabling that scenarios through the REST APIs. And the work that we do there is, I work on those technologies. All right, back to Chuck.
Thanks, guys. So, like I mentioned, this session is all about you. It's what you want to learn, driven by any questions that you have. So does anyone have a question, or do you want me to just start asking? All right. Grant, microphone. Microphone, meet Grant.
I have a question about SQL copy, copying a database inside of a Windows Azure SQL database. If you want to get transactional consistency on a backup, if you're just doing a backpack out, the basic gist is you make the copy, then you backpack out. How is it that you guys are maintaining that data as you make the copy, or can you tell us?
If I understand the question is, if you have a running database on premise, right, and you have some transactions there, how do you ensure that while I'm taking the backup, any ongoing transactions are available as well?
Not on-prem, in a Windows Azure SQL database.
Okay. So
when I create a copy,
right,
in order to do a backup from there.
Okay. So if you only take a backup, any ongoing transactions that happen during that time are not reflected in the backup. So if you restore that backup, those transactions are lost. So what you can do is, if you want to start a new replica, right, that is synchronized and is on sync at all times with the primary, then you need to enable some SQL Server high availability solution. So for example, you could configure database mirroring, right, from the primary replica into a replica in the cloud, or you could configure an availability group in SQL Server 2012. Right? So by doing this, the moment that you start a replica in the cloud, any transactions that are executed on the primary will automatically be synchronized to the secondary. Right?
If I understood correctly, your question was about SQL Azure, not necessarily about the SQL Server running in Windows Azure VMs, right? And you asked about DB copy, not necessarily the backups. Okay, so here is the deal. So a DB copy actually takes a copy of your entire SQL Azure database into another actual database. It's not a backup, it's an actual database that it creates. So what it does is it first seeds it. That, okay, I have this size of the database on this server, I'm going to seed it in another server, whatever target server that you specify. And then what it does is that it does a catch-up. And once it reaches to a point that, okay, my catch-up is already done, it's done. And that's the point in time when your copy is consistent, transactional consistent, and that catch-up is transactionally consistent. So till that point, after that point, you won't get any updates. And at that point, it is actually transactionally consistent with your primary or the source. And after that, they are decoupled. There is no relationship maintained between them. You can take your DB copy, do whatever you want. And the reason I asked is, reason you asked, I believe the question is that you want to take a backpack and take it out so that you have a transactionally consistent copy to play with it. That's how it is done. There was slight confusion because the session is about SQL Server running in Windows Azure VM, but feel free to ask the question. I'm glad you asked the question. I'm glad I was able to answer it. Thanks.
All right, come on, just come on up to the microphones. That's, because if you don't, I will.
Hi, we're in the process of setting up a SQL Server in an Azure VM. And my question, I know there was a white paper that was published earlier this week about recommendations for the best practices on that. I haven't had a chance to read it yet. My question is, typically for an OLTP system, it's customary to separate the data files and the log files onto separate disks. What are your thoughts on that?
Did you have a chance to attend Guy's presentation this morning on performance? Or at least you have a chance to attend Chuck's presentation this afternoon? But I'll let first.
Yeah, a couple of thoughts on that. For one thing, yeah, you probably get some useful information if you go to the replay of my session at 10:15, which was on SQL Server performance. I think it really comes down to what's the total IOPS that you're looking for from both. If the total IOPS that you would want from both your log file and data file, say, exceeds, say, 500, you probably want to put them on separate disks. Otherwise, I would say they're probably okay on the same disk. I don't know if anyone wants to add any nuance to that, but I would basically... Do you want to?
So, yeah, as the guy is saying, unless you have higher IOPS requirement, the recommendation is keep it simple. Keep both data and log files within the same data disk. In the same disk. The other consideration to have is the geo-replication process that Windows Azure has for disaster recovery. This is continually synchronizing those disks to a different data center. Today doesn't guarantee order across different disks. So if you have your data files, your log files in different disks, that geo-replication process will not guarantee the order. That can actually break the recovery guarantees of SQL Server, which take a dependency on something called write-ahead log, right? Always having the log ahead of the data. So to avoid that situation, what we recommend is keep it simple, keep it in the same disk. Only in the case that you actually need more IOPS or your database is larger than 1 terabyte and then you need multiple disks, what we recommend is take a dependency on some of the SQL Server disaster recovery technologies and do not depend on the Windows Azure disaster recovery technology for that.
Okay, thank you.
Now, another thing that I want to add to that, you mentioned the key phrase best practices, okay? In the traditional database on-prem DBA world, best practices live for a very long time. You know, there are some SQL 2005 best practices that still apply as best practices in SQL 2012. In the world of Azure, specifically in IaaS, which is what we're talking about here, best practices will change very quickly. I'll give you an example. When we were in preview with IaaS, one of our published best practices was to move your tempdb files to the D drive of the virtual machine, which is a scratch drive that the machine creates and uses for its own purposes. But there's enough storage there that you could put tempdb on it. And we were, in our initial testing, seeing some very good performance. So out of CAT, we started telling people how to do it. We actually have out on TechNet, there was a script for how to set a startup task because the D drive is completely temporary. If your virtual machine gets migrated to a different host, the D drive gets recreated. So we had a script that would, set the perms and create the folder and everything on startup for you in case that happened. When we went GA, there have been enough changes in the underlying subsystems that was no longer our recommended best practice. So we've altered our guidance on what to do with tempdb because of changes in the underlying subsystem. So you need to, it's a different world that we're going to be living in here. You need to keep up on what the Azure changes are because changes in the storage subsystem, our VHDs are stored in Azure Blob Store. Changes to how that reacts could affect your VHDs and your VMs and would thereby alter your best practices. For me, the best place that I say to start with for major changes in the Azure platform, watch Scott Guthrie's blog. Whenever we put out a major change, he blogs about it. And then we will have the updated documentation on it. But that's a good place to start, is to watch that blog. But just know that we're moving into a different world here where best practices that in the past have lived on for years could now change with a subsequent Azure release.
All right, I was just going to tack on to this discussion as far as in terms of IOPS and performance. It seems like a lot of the big changes that are happening in Azure Infrastructure as a Service are related to the disk subsystem and the performance and capabilities of that. And I'm just wondering, looking ahead to SQL 2014 and Hackathon, does that have any potential implications for other avenues of gaining, with in-memory tables, alleviating some of the performance issues that we deal with now in terms of trying to work around some of these disk issues in Azure.
Yeah, I mean, I don't know if Sunil, you want to comment on the I/O implications of Hackathon, for example. I will just add to what Chuck said is that the Windows Azure blog is also a really good place to check. SQL Server puts articles there as well as Windows Azure, so it's a good place to check. But yeah, Sunil, do you want to maybe comment on the Hackathon? And I think you've run some tests in.
That's right. So I don't know if you had been to any of the Hackathon presentation that I did. Yes. Okay. So the key point that we have is the data is in memory, right? So the data I/O is not as random as it will be for SQL Server because data is organized in a completely different way. So I believe, and this is experimentations we are still doing, that I/O load for the same transactional throughput will be much lower if you have in-memory table, number one. But in terms of log does not really change that much, right? So that if you have a logging bottleneck with SQL, you will continue to have a logging bottleneck with Hackathon. Now there is a interesting point within Hackathon is we provide a version of a table called non-durable table. So a lot of times, if your application has transient data in SQL Server today, you have no choice but to have a regular table, right? With Hackathon, you could say, you know what, for this part of my application, I'm going to use non-durable table. Now then, there is no I/O for data, there is no I/O for log. So there are situations where Hackathon will help you even more, right? So in general, my thinking is that Hackathon will help you because I/Os are very different. And we will publish a white paper on migrating an application from Windows Azure SQL, and I move part of that application to Hackathon. What do I change?
Okay, yeah. Thank you.
Please grab the microphone so that we can get it on the recording. Thank you.
So when you go to your site and you try to, I guess, deploy Windows Azure VM, you have to pick different sizes, and those sizes basically give you memory and CPU. Do you have guidelines as far as the IOPS that each environment can handle? And what are your options if you start exceeding those guidelines?
Yes, so on the website there is the memory, CPU, IOPS, the network bandwidth is all published. I do understand there are multiple links and multiple posts. Some posts show up only the memory and CPU. But if you go to the Windows Azure page where there is a capacity, size, and all this type of information, everything is listed there.
And specifically on the disks, the number of disks that you can have per VM changes as the size gets larger. In a lot of ways, this is done because the underlying physical hardware is being shared, the underlying physical NIC is being shared, and we want to spread that load and have a fairness across those. Our recommendation is to expect about 500 IOPS per disk that you add to the VM. And so the number of disks will actually lead to how much total IOPS you can get out of that VM, and the total number of disks increase as the size of the VM. So the VMs with 8 cores get 16 disks, down to the extra small gets only a single disk.
All right, so I have a question, and this one's going to be directed at my colleague Sanjay. You've done a lot of work on-prem with Always On in SQL 2012. That was kind of your signature thing for that release. How is Always On going to be changing as we move into infrastructure as a service?
Thank you. One quick precursor on that is Always On equal to two things. Always On is a brand name that comprises of two features. Feature one is called failover cluster instances that has been existing for many releases. We have enhanced it significantly in SQL Server 2012 and rebranded it under Always On umbrella. SQL Server 2012 also had a new feature called availability groups that also comes under the Always On umbrella. So on premises, both these coexist. Both these can be configured in an environment together. Both can be configured separately. And we have customers doing all kinds of combinations. when you go to the Windows Azure VM world, the failover cluster instances which requires a shared storage environment that does not exist in Windows Azure VM world today. And therefore, you do not have failover cluster instances on SQL Server in Windows Azure VM. What you have is always on availability groups in Windows Azure VMs, and that functionality is exactly the same as what you have on premises, and there are some gaps right now at this point. As we go in next few months, you will see the complete feature parity. For example, today we do not have a listener, but it's coming very soon. If any of you here had a chance to attend the presentation Luis, myself, and Corey did on Tuesday, and we repeated it on Wednesday, that was on high availability and disaster recovery for SQL Server running on Windows Azure VMs. We talked about various scenarios. I urge everybody to go and see the recording and the deck. We talked about various scenarios, and that scenarios include how you do always-on availability groups within Windows Azure VM, within one Windows Azure DC, how you do it between an Windows Azure DC and on-premises, and what are your HA and DR options today between two Windows Azure DCs. Luis, would like to add anything to it?
So just out of curiosity, how many of you have been using availability groups or is familiar with availability groups? Okay, so most people. So one of the interesting things that we did is we actually improved some of the aspects of availability groups based on infrastructure as a service. So based on some of the requirements that we have for Windows Azure, we actually improved the product that will now reflect also for some on-premise environments. So one example of this is making sure that in disconnected environments, so environments where you have largely geographic distributed environments and your primary is in one data center and you have multiple secondaries distributed across the country or even across different countries. Today in SQL Server 2012, there are certain scenarios where if you lose connectivity at the network level for more than, I think, half a minute or so, your readable secondaries, those secondaries that you could use to for reporting, for example, or for backup purposes, will kick out connections. So if you're currently reading from those readable secondaries and they lose connectivity from the rest of the world for more than a minute, they will basically kick out the connections. So we know that in the scenarios like IaaS where connectivity, for example, over the internet may be glitchy at some points, we want to remove that. So we actually improved the product, and so that now in SQL 14, even if you lose connectivity, right, even if you disconnect the cable between that readable secondary living, for example, in a Windows Azure data center and the rest of the world, you will still be able to use that readable secondary. So your reporting applications will continue running. Your backups, if you're taking backups on the secondary, will continue working. So that's one example of how we have actually improve always on for some of these new cloud scenarios as well.
So I've got another question about, this one's about the Azure networking stack. We have virtual networks in Windows Azure, and those went GA with infrastructure as a service. And there's a couple new things that I saw, and one existing thing that I'm not still sure about. So if you go into your virtual networks in Azure in the management portal, you see something called local networks, and you also see two options that are now in preview, the point-to-site and the site-to-site. Can you guys just kind of talk a little bit about that and how we would use those as DBAs?
All right. So virtual networks, virtual networks in itself is a concept that we've had for a while, and it went GA with, as Chuck was pointing out, in April. It is so that we've always had one technology which is called site-to-site, and what we had was an ability for you guys to define a network with a virtual network that is private within Azure and actually deploy your virtual machine inside that. So in this case, you could deploy a virtual machine, have your SQL Server configured, your primary configured, or your secondary here, and this site-to-site connectivity will essentially establish a secure channel between this virtual network. So we'll have a gateway sitting at the front edge of your virtual network connecting back to your on-premise. And on the on-premise side, previously what we had was an option for you to spin up a hardware device like Cisco or ASR. But with the new features that we released in April, we have two different options, which is called point-to-site connectivity and site-to-site connectivity. So with point to site, the ability that you get is, let's imagine a case where you have the virtual network set up, you have a gateway, but we have a way in which we can generate some network connection profiles and an exe that you can go and install on your laptop, and then you can directly connect from your laptop. Your VPN connection, a secure VPN connection, can be established from your dev box or a laptop into Azure. So now you have a secure connection into having your accessing your virtual machines. Now, how this is useful is because let's say you're developing an application, say that uses a SQL server that is sitting inside a virtual machine on Azure. You can, since most of this, when you host a SQL server, it's a data that you don't want to put out on the internet. So what we can do is we can have this virtual machine turn off all the endpoints, delete all the endpoints on it. But if you have a secure connection back to your developer box, now all that this developer box has access direct to the virtual machine through the secure channel and just the virtual network, but not on the public internet. So that's one cool feature that we enabled. And some of the always-on availability group scenarios that Louis has been talking about can be enabled through site-to-site connectivity, where you have hybrid connection established between Windows Azure and your on-premise network. So you have your primary sitting on-premise, but your secondary sitting on Azure, and you have a secure transaction, and everything that happens between them is using the site-to-site connectivity that we just recently enabled. And with site-to-site connectivity, we had another nice little feature where now we removed the dependency from the hardware devices. We also added hardware devices, and we also have Windows Server 2012 RS capability, where you can just spin up a Windows Server 2012 box, enable RS, and use that as your gateway instead of a Cisco or a hardware device. So those are some cool technologies that we just enabled recently.
So again, with Windows Azure VMs, and one thing I haven't heard a lot of is monitoring. So obviously we have monitoring set up on our VMs, and it ties to our ticketing system so that we get alerted and get paged and this and that, and there's tracking. We're not a system center shop, though. So what are our options there?
So when it comes to monitoring, there's a couple things you can do. One, if you have a solution that you use on-premise with that site-to-site connection, whether it's a hardware-based or a software-based using Server 2012, you can use those same tools. So whether it's System Center, whether it's HP OpenView, any of those tools, it's essentially like managing a server in a branch office. And so best practice is to look at the guidance from those tools on how you would monitor a server in a branch office. And those typically apply to Windows Azure because it's very similar. You get the latency that you would tend to see when connecting to a branch office server. You also have the option to run those management tools strictly inside of Azure if you choose. Run the server-side products and the agents on those machines if you'd like. In addition to that, there's a few tools coming online, both from third parties and things are coming from Microsoft that are SaaS-based, software as a service-based solutions for monitoring. Those traditionally are focused more on the platform as a service roles, but a lot of those can be used on infrastructure as a service VMs. And again, they're very similar to as if you were using them on-premise. A lot of them have an agent that's installed, and you just got to be able to make sure those machines can connect into those virtual machines, whether that's through a HTTPS port to the machine, WinRM type port, but some way they can access those machines. But by far the most common thing is to use the current products that you would be using on-premise, run the server-side component on-premise, and then monitor those machines as if they were branch office servers being monitored.
So we use a product called Tivoli from IBM. And as far as I know, how that works is you actually have a service running on the Windows machine itself. Is that something that's feasible? Can we do that? So we can actually run a service on the machine?
Yeah, so with your infrastructure service virtual machines, you have full control. You have full admin rights, and you can install services, agents, whatever you would install on an on-premise box can be installed on those machines. Absolutely.
Yeah, that's one thing I want to...
remote desktop, or it's all through the Windows Azure console?
You would typically... well, and it depends. Some of those services, I'm not sure with Tivoli, they will actually reach out to the machines and do a self-install if you give them admin credentials. And if you're using the site-to-site VPN connection, you have full IP, TCP, UDP connectivity. And so most of those tools will be able to reach right out to the machine in Windows Azure and configure it. If you do a manual install, the easiest way is to remote desktop into that machine. The other option that you have is to use remote PowerShell. So you can do a remote PowerShell session. There's a set of blog posts we have up on that, and then execute that from a command script remotely to install those agents in the same way that you would if it's like for an MSI package or something like that. But basically, you do just treat them just like you would any other physical or virtual machine through the installation of those services.
Okay. What about the size limitations for the database? I think in SQL Azure it's 150. Is there a size limitation on Windows Azure?
So on Windows Azure, the size of the database is limited to the size of the persistent disks. So you can, like I was mentioning earlier, on the extra large VMs, you can attach up to 16 persistent disks to the VM. And each persistent disk is up to 1 terabyte in size. And so you effectively have 16 terabytes of capacity to use for your SQL Server database.
What I was just bringing up on the screen here is the Azure Management Portal, where I have several virtual machines running here. I happen to have 2 database servers that are functioning as an always-on availability group pair. So if I want to connect into this machine, all I have to do, I'm doing this through the portal right now, but all this is giving me is an RDP file. That RDP file I can then use just to connect up to that machine, standard RDP protocol. It's going to prompt me for my creds. In this case, it's TechEd BI. Don't they tell you never type during a presentation? So it's just like our connecting up to a machine in my data center. I can remote into this machine. I can do anything I want with it. Now, if I had a site-to-site connection where I had the permanent VPN tunnel between on-prem and that machine, I wouldn't even need to go to the portal. I'd just be able to use either IP or the machine name. Same thing if I had a site or a point-to-site connection, which is what I do when I'm building these environments out. I have a point-to-site connection from my local machine up into my Azure VNet, and I can just address those machines by name on the network just with the standard remote desktop. You can use RDC-Man, whatever tool you want to use to remote desktop into it. But one of the things I like to tell people when I'm talking to them about Azure, and virtual machines in particular, once you instantiate it, there's very little difference between a machine running in Azure and a virtual machine running in Hyper-V in your data center. Very, very little difference. Things that you probably won't even notice, like the D drive and that, and the multiple disks. These are things that the experience to your users and the people administering these machines and working with these machines, you're going to use the same tools you're using right now on a VM running in your data center, for the most part. So that's one thing to remember. It's just a VM. That's all it is. It's a VM. Happens to be hosted in Azure instead of in Hyper-V on a server in your data center. Are there any other questions? Or should I keep talking?
How many of you have been playing with Windows Azure infrastructure services? Okay, wonderful. Things that you like. I'd like to hear them.
Yeah, this is your golden opportunity. If there's things that you like, if there's things that you don't like,
yeah, things that you want us to
these are the
improve.
guys that can affect change.
Things I like. One, it is just a VM. How glorious is that, right? It's simple, it's straightforward. I can explain it to anyone. So it's great. 2, the fact that you're doing that hybrid approach, that's fantastic with the whole high availability stuff. Actually, I have a blog post coming out on Monday praising you guys for that. Well done. That's it. I'll stop.
Okay, thank you. Please, yeah, please go ahead.
The one suggestion I'll make is, and I'm sure you guys probably have put a lot of thought into this already, but why so few options as far as size? Why not give a little more customization? as far as CPU, memory, and that kind of thing?
So with Windows Azure and data centers around the world, and thousands upon thousands of machines, one of the challenges is getting that consistency, getting that hardware, getting everything out and available so that people can deploy, whether it's in the US or in Asia. And so getting to that level of consistency does take time. The more machines and more variations and more different sizes that we have is a challenge there. Now, as you've seen, Windows Azure, when it first came out, there were 5 different sizes, and they were all ratios of a single core to 1.75 gig of RAM. With some of the things we've done with Windows Azure Infrastructure as a Service, especially working with SQL Server, there's a very clear point where certain applications work much, much better with larger amounts of RAM. So that's an area where, and we knew this going in, and we've been investing and adding those out, getting that hardware out to the data centers to make available. We're doing the same things. We're working on new hardware to get that out. It's just things that take a little bit of time to get it out to the thousands and thousands of machines across all of the different data centers to make it really available worldwide. But it's absolutely true, and you'll see these continue to grow and the options to expand on what kind of hardware you can use for your different applications.
You were asking what I like about VM1 is that there's nobody I have to talk to build out a whole farm of machines. One of the things I don't like is that there's nobody to talk to when I want to build out a whole farm of machines. It's kind of a situation where I can do everything, but then I have to do everything too.
By that, are you talking needing some guidance, some help?
The guidance has actually been pretty good, although it's changing literally daily, and I'm changing what I'm doing based on stuff I read the night before, and that's happening every week. But I think, one of the examples, like it's fairly hard still to find when scheduled maintenance was planned. I follow the blogs, but there's no RSS feed that's just when there's scheduled maintenance. So it's hard to eliminate problems in the data center from problems in my stuff.
Yeah, that's great feedback. I mean, that's absolutely an area where we're investing, both for some notifications, especially if you have single instance VMs. If the machines go down, that can be a really disastrous situation. If you've set up failover or always on, then that's going to be a little bit less of an issue. The second point is, what was the failure? Was it what I did or something else? One thing you can look at is when the machine is shut down from within the hypervisor. You can look at the event logs, and it says who shut the machine down. If it was shut down by the hypervisor, it was either because of a the underlying OS being updated, or it was initiated through the portal to say shut down the VM. Now, you can determine which of those it is, because in the portal, if you go down to the bottom section, I think it's under settings, you can list out the actions that have been done on that subscription. And so you can actually look through there and see if it was a user initiated through the portal shutdown, or if it is done by Azure. So there's some things that you can do to get an idea of what's happened. There's more work that we can do to give more telemetry from within the VM of what happened, some more guidance on how to build that out. And that's absolutely what we're doing, some of those areas, listening to the customers to really give that clear understanding of what happened, why did it go down, or why did it move, get a notification before it goes down. So that's a great point. Now,
so correct me if I'm wrong, but to achieve our SLA that we guarantee, you have to have 2 VMs in the same role running, correct?
That's correct. So I'm going to ask you as a customer. Okay. So I deployed my application on Windows Azure, and I have my SLA for 8 to 5. I mean, I cannot let my machine go down, but the SLA that Windows Azure team is providing for my VM may be different than what I need from the time duration. So the point is, the maintenance operation that I need to do on my VM, I mean, I have a fixed time that this is the only time that can be done. How do I communicate that to Windows Azure team that this is a blackout period for me? Don't touch the physical machine that is hosting my VM. I don't know whether I'm saying it correctly or not, but that's...
So the question, let me just make sure I'm understanding, is there a way to indicate to Windows Azure, don't take the machine down at this point in time? Right. So with Windows Azure, we don't have a specific, so again, we look at the machines and we actually treat them, whether it's a single instance versus a multi-instance, in two separate ways. So a single instance, because, and the different, what we call a single instance is, if the machine has not been put into an availability set, that's what we treat as a single instance. So these two are in an availability set. That's what we call a multi-instance. And so you've indicated to Windows Azure that those two machines are performing a similar role. Do not take them down at the same time. Spread them across fault domains. So in the case of a single instance, we do treat those differently. Those are the ones where we will give you a notification on when it's going to be updated. And so in that one, you don't necessarily get to tell us, but we're going to give you a notification. What we're looking to do is make that in off hours. There will be an off hours time around the world, off business hours. And so and we're looking at about a 48 hours notification. So you'll get a notification saying, here's when those machines are going to be updated. And it's actually not updating your guest machine, but it's patching the underlying host hypervisor. At that point in time, you wouldn't want to be doing your own patching because the machine's going to be shut down. In the case of the multi-instance availability set, those will be taken down. You don't get quite the level of notification. But one thing that happens there is that we always update those machines, again, not at the same time. And the other thing is there's always an interval between them. So one machine will be shut down so that the host hypervisor can be updated. That machine will be brought back up. And there's at least a 10-minute delay before the second machine is taken down. So one thing that you'd want to do is, before applying a patch on either of the machine, is to look to see make sure its partner is up and has not been taken down, or has not just recently went down. If it just recently went down for updating, it would be better to hold off because that machine is likely going to be going down in a moment. You want to let the replication continue. So that's really the best practice that we have right now. Again, we're looking to do some more notifications even on the multi-instance machines. Our focus initially has been on how to get good notification for the single instance, because those are the ones you really don't have another partner for that. But then we'll continue on that to get notifications on the multi-instance.
So to answer to your question, so this is a paradigm shift. How applications used to design, develop, and maintain in on-premises world, things are different how things happen in a cloud world. In on-premises world, the app team will actually say to the data center, my peak periods at this time, do not touch my boxes, do not touch anything. In a cloud world, when it's an ocean, there are thousands and thousands of racks, thousands and thousands of machines, thousands of network cables and whatnot. Things will fail. Things will fail. Things will be maintained. Things will be maintained because they fail. Things will be maintained because they do not fail. So all these things will happen. You are taking a dip in an ocean. So how do you prepare yourself to protect from such events? That's the new paradigm of application design. So you do not, instead of you saying, okay, I have been doing it this way, I have been telling the data center guys, do not take my machine down. Rather, I'll take the assumption that machines will go down when I do not want it to go down. And therefore, how do I prepare to stay up when my particular VM goes down, either because of a planned maintenance or because of an unplanned failure? So I go and set them up in availability set. If it is a non-persistent role, for example, if it is you're running a web role or something, website or something like that, or if you're running on a persistent role, for example, you're running a SQL server on it, you put them in availability set, and then on top of that, you put availability group. That's how you protect yourself from these known and unknown events, which do happen all the time. In a cloud scale, every second some machine is going down. Every second some switch is going down. Every second somebody somewhere is going down. And you got to be ready for that.
So now when we talk about patching, okay, you mentioned patching.
Follow up as well.
Oh, sorry. Go ahead.
Sorry, thanks. I just wanted to check, when you were looking for guidance, did you try the public forums at all? And if you did, were they any help?
I needed to get information from the Watts team, and that's where I had major delays.
I see. So it probably wasn't something that you could necessarily get help from a public forum for in that case.
No,
Right.
I don't think so.
Yeah.
So now we talked about patching, and this question came up in one of my sessions the other day when we were talking about IaaS, and so I'm assuming more people are thinking it than I really know. We're talking about patching the host machine here, correctly? We aren't going in and logging into your VM and patching your guest VM, correct?
That is correct. We're talking about Windows Azure updating the host machine that's part of the Windows Azure environment.
Yes, because that was one person's concern in this session, because like, well, you're logging into my machine to do patching? No, you control from the OS up, it's yours.
So just a tip as well. So by default, Windows Update is installed and configured in those machines. So even if you put all of your VMs in the same availability set, it could be the case that Windows Update tries to go and update all of them at the same time. So I learned this one time. So make sure that when you configure Windows Update, either you configure it so that even if it downloads all the updates, you install them whenever you want, or set up the schedule at different times so that they're not impacted at the same time. Another tip as well, ideally make sure that you put your VMs within the same virtual network, the same VNet. And the reason is that if the host fails and those VMs are service healed and restarted in a different host, the IP of those VMs will change. And that means that at the DNS level, there will be an update remapping the name of the VM to the new IP, and that can take around 12 minutes. So that's 12 minutes that you may not be able to connect to the new VM. So if you put those in the same VNet, the IPs remain the same, so you can automatically, after service healing, reconnect. So just some tips of how to increase the availability of your VMs.
The question was, are the VMs running core? Do you mean the host or the actual guest? So the guest is typically, all the images in the gallery are running the full version of Windows. There's nothing to prevent you from running core. We just don't have that in there as an image. If you're running core, you'd want to make sure to enable PowerShell and do a lot, if it's 2012, it's already enabled. But you'd want to do a lot of your management on core then through remote PowerShell, most likely. But VMs by default are running full server.
And the other nice thing about Windows Server 2012 there is, even though it's full server, you can uninstall the GUI and turn it into core. So you can take these VMs and make them core, or you can build your own VM on-prem and upload that VHD and use that in the cloud. That's another thing you can do with our service.
Just in regard to these update questions that we were just talking about, so on the infrastructure side, Azure is going to be taking down instances for the purposes of backing up the underlying system. And I think you just said, check to be sure that your instance A hasn't been rebooted for that purpose recently. But then we just discussed scheduling Windows updates so that they don't happen all at the same time. But what happens if the backend takes down your server A and your scheduled Windows update takes down server B? How do you avoid that crisscross?
Yeah, so the question is, it's on the mic. With Windows Update, Windows Update is something you want to be a little leery with. I mean, honestly, if you're running a production service, Windows Update may not be the best solution to use, because it's going to, when the patches are available, it's going to take them and it's going to install based on the time that you select. Now, you can set the times to a different range so that they're not going to be at the same time. You do still have that slight risk of the machines, one's rebooting for Windows Update and the other one is being taken down for updating the actual Hyper-V. We don't have that telemetry to know and to hold off the update of the host because one machine happened to be shut down or is rebooting. So you're likely going to be in a better situation to disable Windows Update and use WSUS, or some other tools to give you a little more control of the patches instead of using just Windows Update directly.
Or just to install them manually.
Or to, yeah, you may want to, and you can configure it to download the updates, but not apply them automatically and apply them manually, which is actually going to give you more control. It's probably the right best practice for using that in Windows Azure when the hypervisor will be updated at different times that you don't necessarily know.
And in terms of checking whether or not a server has been recently, you recommend looking at Event Viewer, basically?
Using the Event Viewer is the one that I find the easiest to figure out the reboot and the reboot reason. You can actually look at that, see what the reboot reason was, where it was initiated, and determine that it was a hypervisor-initiated reboot. And that gives you a really good indication that that was done likely from a patching event on the host. That's by and far the most common reason we will take down the machine is for updating the host. Very rarely we do network level upgrades. It's about on an annual basis today where we need to update the top of rack switch. When we do that, those machines will be offline for that purpose. But again, they're going to be shut down gracefully, and so they're going to look about the same. You can treat them the same. It's also done across the update domain, so they're not taking them all down at the same time.
Okay, and just in regards to sort of likes and dislikes or pain points about using the infrastructure as a service stuff, I guess one thing we've run into have been some quirks with the load balancer in relation to Azure VMs. And I just would say any more work you guys can do to make that less issue prone, and I can talk to any of you guys about the specific issues we faced, but less issue prone and maybe more configurable, have more features like sticky sessions and things like that, so that would help from an app perspective, an app hosting perspective.
Sure. So sticky sessions is definitely something that we are looking at the load balancer level. So that's one of the biggest asks that we've had. So we are working on it. We don't have a timeline, but that's something we're looking at. But in general, while using load balancers in Azure, like load balancing your traffic for your virtual machines, did you have any other problems or anything that you felt was?
Yeah, specifically. So we're hosting two ADFS proxy servers in Azure. So it's HTTPS service. They're Azure VMs, and we configured them via the here's how you configure the load balanced VM pair.
Right.
And all of that went fine, but we found that if one were to go down, or if we actually even if we shut down one of the instances via the Azure portal.
Right.
Certain requests would still route to that server.
Okay.
And as I've been going back and forth with some support techs, and it seems to be related to either some errors or issues with the default way of configuring that via the portal, also combined with, that there's also PowerShell commands, obviously, to be able to do some of those things manually, and there's some bugs with the PowerShell related to that.
Right.
So there really was no workaround at this point for us.
So that's a good question, and it's kind of a known problem that we've been facing. You pointed it out correctly that we did have a problem in configuring the default probe when you set up the load balancers. So the traffic that was being routed, was routed to the second instance, even though that instance was not up and running. So if you configure it, so we have made that updates, and if you configure load balancers now, your load balancing should be set up correctly starting June 1st week, right?
Okay.
So if you use Portal or PowerShell, and by default, when you set up load balancing endpoints, now we are configuring the default probes on your behalf so that you can actually load balance the traffic, and if one instance goes down, we learn that that instance is down, and we route the traffic only to the other instance.
Right.
Now, but for existing deployments, like the one that you probably have configured, I would recommend you go and take a look at our PowerShell commandlets, and there are some settings which specifically talks about configuring the probe port and all of those settings, and if you can go take a look at that and you can list it out, you can get the endpoint, look at the probe port and see if it's configured at all, and if it's not, I would recommend you go configure the probe port by yourself, and then your settings should be up and running.
I mean, this sort of gets to one of the things about, how do you find out the issues and how do you deal with it? I mean, the fact that the load balancer did not work up until this month, as you would expect, as anyone would expect a load balancer to work in terms of availability, is a huge issue. And it's one that I would have expected some major posting, some major publication to say, hey, this is a big deal. So if you're following the guidance that we have given you in the past, you need to do these other things, or we're working on it, or whatever. And so that's just in general, that's the type of thing that, from my perspective, makes it hard to go whole hog in SQL on Azure or anything like that, because I wonder what are those things that are underlying that I haven't heard about because I'm not testing that out yet. What are the things that are lurking out there, I guess?
Yeah, that's a great point. The things that are little items that we know about, have discovered, and we want to get out there. Some of that's in the forums. Some of that we get into a post that we put up there as a sticky post. There's more that we could do there, and I think even let me just turn this. Would you want to see something more as a blog that's continually updated, forums? What would be the best way to consume those?
Something official and centralized. Some defined place that we would go to look for known issues, best practices, types of things. And I know Microsoft is a big company, and there's probably 10 of those already for every single feature. But just that's just one of those things.
That's a great point. And I just want to also add to what Mahesh is talking about. So if you have a machine that's already configured, there was an issue is if you set up in the PowerShell before the set that was just released this week, you didn't have the ability to change the probing ports on the machines that were in a load balance set. The new set of commandlets do allow you to do that by changing the load balance set, and it will change the probe port on all of those. The portal, when you set up an endpoint, previously it was not setting up a probe at all, and there's no way to configure a probe outside of PowerShell. Now the portal will set a probe at the same port on the local machine as you've opened it up, because that's the one we say. If you open up HTTP on 80, then we say, hey, that port must be opened in the firewall, and we set up a TCP probe there by default. And if you want to move it to another location, you can use the PowerShell tools to change where you want to set the probe ports. Or if you want to use an HTTP type probe where the machine is able to respond with a 200 or not, if it wants traffic or not, then that's also available through PowerShell. And we're working to get that functionality into the portal. And you'll see this a lot, and if you've been working with it, that a lot of the functionality will come out in the PowerShell first, and then it will come into the portal. The portal tends to stay at a little bit higher level to make sure it's easy to use. But as these features and functionality are disseminated and well understood, and more people are using them, then we get them into the portal in a nice, easy way to use them.
Any other questions, or?
So I think you already pretty much addressed this with your discussion about the paradigm shift. I'm sorry, I'm going back to the patching. And I'm just, I get it, right? I understand what you're trying to say, and I'm just trying to think through how I can explain to the big guys who make 70% of their yearly revenue on Black Friday that your servers might go down during that time frame. Everybody understands that you have some period of patching that you need, but I'd sure like to put an exclusion on something. Say, don't mess with my servers this week. I don't know.
So just as a comment, a way to protect you or minimize this is also to increase the number of replicas that you have within the same availability set, right? So it's very unlikely, especially if you configure when to do your guest OS patching, that you'll have multiple of these failing at the same time. Windows Azure Upgrade will ensure that only one of those machines is taken down at the same time. So again, by increasing the number of replicas from probably 2 to 3 or 4, you really minimize that.
And this is probably, even especially on the front ends, a bigger issue. Those you can scale out larger than your databases themselves. We give you, by default, 5 update domains, and so it'll spread across those. And so as you add 5 or more machines, we're going to take down no more than 20% of those machines. We're also looking at expanding that to give you more update domains to take down a fewer overall percentage of machines at any one point in time. But that's a very good point.
Basically, I wanted to highlight that we have a concept of fault domain and update domain. When you configure virtual machines in an availability set, they get spread across these fault domains. And we do not take more than 1 or more than 20% down at a time to ensure that you have not lost your other components within the same availability set. So that's the way you go about and design it for that kind of scenario. And if you're designing for SQL Server, then of course, as Louis said, you put them in availability set and then have multiple replicas so that you can fail over automatically from one to the other, and you're protected.
Yeah, one of the things a colleague of ours on CAT always stresses is when you're designing for the cloud, design assuming that everything's going to fail. Build your applications, build your systems, assuming that the next step down the line won't be there and that you have to handle it not being there. Because if you build it that way, things will just work. You have it handled, you deal with it gracefully, you move on, you do what you need to do to make sure your system as a whole works, even if things along the way break down.
One additional thing that we've just enabled that can help in this to a certain degree is just this week we've changed how we do our billing when a VM is stopped. So another option is, especially when you think about the Black Friday type of situation, you can set up your machines, set up your instances, test them out at a much larger scale, and you can just stop those machines. And at this point in time, you won't be charged for the compute usage of those machines. You just charge for the storage. And so you can have a set of machines really at the ready that will be very rapidly able to spin up. It's essentially just the machines getting put on a physical host and being booted up. And so very rapidly you can scale back into an environment that is much larger than you have right now. This is one of the things, so you have pros and cons with the cloud. This is one of the things that the cloud gives you, that you can have those just ready, and if you don't use them, you don't pay for them. Where on-premise, you would have to know in advance exactly what you want and either overbuy just in case or underbuy, and it can be a really tough thing. So you definitely get a little additional work to figure out and be aware of the systems can fail. However, the flexibility of having systems at the ready is also a very nice thing in the cloud. So when you really look at the full TCO and the risk analysis, there's things on both sides that you want to be aware of and think about.
And another thing that we've done, this was released with SQL 2012 SP1 CU2. You now have the ability in SQL Server to sysprep almost the entire installation. There are still a few things you cannot sysprep, but you can now sysprep almost the entire installation. So what you can do in Azure is you can create a virtual machine, you build it, you sysprep the SQL Server side of it, and you can save it as what I have up on the screen here, the virtual machine images. So now if I wanted to spin up a new machine, I'll use my SharePoint image as an example because SharePoint's a great scale-out example that scales very well. If I want to add a new SharePoint machine, I just come in and say, pick one from the gallery, but I want to use my image, and I want to use my SharePoint image. And I walk through this tool, and this is even better through PowerShell, because in PowerShell you can do things along the way like having it automatically join your domain. So at that point, you run the PowerShell command to instantiate a new VM off of this template. It automatically joins your domain. I can run a remote PowerShell script to say, join the SharePoint farm. Within 30 minutes, this machine is up and running in my farm servicing requests. Really, really powerful. Anyone else? I know there's a couple people that have been sitting here quiet. Are we putting you to sleep? Just nap time?
Anyone had any blocking issues? Which means that because you don't have X, I'm not able to deploy application A in Windows Azure Infrastructure as a Service. This is your opportunity.
You've got open ears, and you've got a GPM hiding in the back of the room that'll listen to you too.
Higher. How much higher? Okay. Today we have 500 per disk, and you can have multiple of those disks assigned to each VM depending on the size. The largest VM we have today can have 16 of those disks. So 16 multiplied by 500 is that much you can have IOPS. How much more does your application need? And can you tell us a bit about your app?
So we run about 6,000 batches a second. So we do a lot of IOPS. We're currently looking to implement something like Fusion I/O cards in our production servers, move away from hard drives on the SAN. So if we are to ever consider doing things in the cloud, we're definitely going to need a lot more than just 500 IOPS per LUN.
Any range of what?
We're probably
Any idea on the range of IOPS you?
We're running. We're at the very least we're pushing 15,000 IOPS a second. That's typical, but we go higher than that.
So as has been mentioned multiple times, there's constant improvements happening in the cloud. So this is definitely an area we've heard. We've been investing in the storage infrastructure to really build out for Windows, for the infrastructure as a service. Work will continue there.
So somebody in the, I guess the Expo Center showed me a website where you guys have these cost estimators where you could throw all of the, could one of you demo that?
Sure. Go ahead.
Yeah, it might be kind of quick. I guess I'm just wondering if there's any, I don't know, guidance or white paper or anything around using it in a PCI compliance state. Is there, I don't know, is there either with a mix of your PCI zone inside and connected up there, or just PCI compliance up there? Do you know what I mean? Is there any sort of special setup or anything?
We have a website that's called Windows Azure Trust Center. So if you go to the Windows Azure main portal, there is a Trust Center, and that lists out various services and what kind of compliance level each of those services give you. And that would be probably your first place to go and take a look which all the items are what kind of compliance ready.
I got it. So if you go to windowsazure.com and pricing, you have a calculator that walks you through the different prices that we have for the different services that we offer. And as you go through, you can go back to the full calculator to see what are the different things that you could do. Here, the Windows virtual machines is the virtual machines that is the infrastructure services that we were talking about today. There are different pricing for the pricing is based on the different sizes of that you choose. Right, as we were mentioning, there are different cores that get associated with each size that you pick and a specific type of RAM. So we have from extra small, which is a shared core, back into A6 and A7, which are memory-intensive VMs. And if you look at them, they have 8 cores and about 56 GB of RAM. And you could, this just talks about the per hour usage, right? And this is just about. I chose one virtual machine, and it's charged at like $2.04 per hour. You can also walk down and look at the different pricing for SQL Server images. So we have a different pricing model for SQL Server images and BizTalk and other services. So you can, once again, they offer very similar types of sizes, and you can adjust and play around with it. And the other thing, the interesting thing, if you're using PaaS services, which is platform as a service, we offer web and worker role instances, and you can also model the pricing for that as well. The one thing that you need to remember about virtual machines is the cost is not just the cost of the compute. It involves the cost of the compute, the networking, egress cost, anything that gets out of the data center. And you also have to think about the storage costs, where your disks are essentially backed by your blob storage. Right? So the cost of storing the drives is something that you need to think about as well. So you need to model the storage, you need to model the networking, you need to model your compute, and if you're thinking about virtual networks and if you're thinking about hybrid on-prem connectivity, then you need to think about the cost that is associated with keeping that virtual network up and running. So I'll show you a quick example of what happens. In this case, right now, virtual network is charged based on the connection hours that we have. So if it's pretty cheap, but you can model, you can account for that as well. The one thing that, in general, that you need to think about if you're looking at going production is also the support policies and the costs that are associated with support, because there are a lot of advantages that you get by buying in support as well. So that's a quick walkthrough of things that you need to think about while doing the pricing.
So the cost of the VM usage, that includes the Windows Server licensing, correct?
Yes, yes.
And for our SQL gallery images, it also includes the SQL Server licensing, correct?
Yep.
So now, if I have software assurance with license mobility, I can take my on-prem licenses, and I don't want to use the gallery images, correct, for that, gentlemen? If I'm doing license mobility, I don't want to use the SQL gallery images. I want to use the Windows gallery images and install SQL myself.
Yep.
Okay, because if you pick one of the SQL gallery images, you will not only be charged the licensing fees for the Windows Server, you will also be charged the licensing for SQL Server. And if you're using license mobility, where you're bringing a license along from your enterprise agreement with software assurance, you'll be basically double paying.
I just want to add on to that. As we mentioned earlier, Windows Azure, the platform, is not looking into the VM. And so a common question people have is, if I take the one that's a SQL Server instance and I turn off SQL or I uninstall SQL, do I stop getting charged for it? Again, we're not looking inside the VM, so we don't know what's going on. So we wouldn't be able to stop charging you for that. Similarly, if you take a box and you install the SQL Server product on there, we don't have an ability to know that you installed it, and don't expect that Windows Azure is billing you for that if you didn't install the SQL Server image out of the gallery. So to get the license on a per-hour basis covered by Windows Azure as part of an Azure thing, you must install SQL Server out of the gallery. If you are bringing your own license, you either bring your entire VHD, which is Windows, that has Windows Server and SQL on it, or you start from the Windows Server image and then install SQL Server on top of that. And again, because you started from Windows Server, the platform just treats that as Windows Server, and we don't look inside that and determine what's going on. The one other piece that I really want to call out here is we've just introduced a new set of MSDN benefits where if you have an MSDN account and you run under that account and you run the SQL Server image, that one you're not charged for SQL Server, and in fact, even that one you're not charged for the Windows license when you're running it under this new MSDN offer that's specifically for development and test. When you run that, you're going to be charged at the rate for Linux. And so that one changes, and so if you're doing dev, test, and you have MSDN, then you can select any one of those images in the gallery, whether that's SQL Server, Standard, Enterprise, BizTalk, those, and they're only charged for the compute price, which is effectively our Linux price. And so you can look at the Linux rates and see what it would cost you to run for development and test purposes.
All right, and with that, we are out of time. So I'd like to thank you all for being here. I'd like to thank our panelists for being here answering these questions. If you have any more questions, we can hang around for a couple minutes while the next group gets set up. But enjoy the rest of the conference. Enjoy the attendee party tonight. Hope to see you next year at TechEd 2014.